I'm excited this week because I have been using Heroku for about 15 years. I mean, it's been a long time that I've been using Heroku. And for the majority of that time, I have either run my own workloads on Heroku or helped other people run workloads on Heroku. You maybe didn't realize it has not gone away. It is still a great place to basically, it's the easy button for AWS. So my friend Betty that works at Heroku now, we're having a conversation and we thought they're building their new platform on Kubernetes. They're building all sorts of AI tooling and services for the rest of us. So we've been working on for 2 months now to get this show together, and I'm excited to have my guest on. Julián, what's up?
Hey, Bret. Hello, hello.
Julián, you're a principal developer advocate at Heroku. How long have you been there?
That's right. I've been in the company for 6 years now.
Yeah, that's a long time in tech.
Yeah, it is. But I've been in the industry for way longer than that.
What's the catch up of the last 6 years of Heroku?
The last 6 years, well, it happened a lot. So first and foremost, Heroku engineering team has been working on the next generation platform. This has been a full refactor of the infrastructure behind Heroku. Now it's running on like Kubernetes artifacts, using cloud native build packs, because the current generation or the Cedar generation of Heroku used build packs, but it was kind of like a proprietary version of build packs, not the standard that it's part of the cloud native foundation. And adding like open telemetry support, keeping everything up to date, making sure that the platform keeps growing and maintaining that developer experience that the people is used to. And recently, we also have been working on, of course, AI, and the AI products that we recently announced pretty much last week are pretty exciting. And this is pretty much what we are going to be discussing today. So yeah,
Yeah.
we have been very, very busy here at Heroku. And the other part, well, there is people that don't know, Heroku is part of Salesforce. We have been part of Salesforce like for around like 12 years. And we also have a great story for Salesforce customers on integration. How can they extend their Salesforce applications by relying on compute on Heroku? There is a bunch of people working behind the curtains to be able to maintain the illusion of magic
The
that
illusion.
these platforms offer, of course.
Yeah. So, okay. So this year, if I'm getting this right, Heroku announced
Running on Kubernetes, the applications are running with cloud native build packs now. It has native open telemetry support. Now you can like connect the metrics that the application generates to any like open telemetry enabled dashboard. Heroku was renowned for, okay, this is a platform for small companies, startups, students, but the reality is that this is a platform that big companies use. We have large customers that are using not only the compute that we offer, the platform to deploy the applications, but also the data services, PostgreSQL, key value store, the Apache Kafka for Heroku that we maintain, and the whole ecosystem of other add-ons that other third parties and partners bring into the ecosystem. So it's for any type of workflow that you can imagine. And with Firm, one new thing is that the dyno formation, pretty much the dyno is where the application runs. You could see it kind of like as a little pod or the virtual machine. The dyno formation for Fur is way more dynamic. So you can select both between what is the amount of CPU you need, the memory. They're like different sizes depending if your application is CPU heavy or if it is memory heavy. So it's way better to have more granular control on the costs and the needs of your application. Cedar has like different sizes of dynos, but it is not as dynamic as what Fur is offering.
Yeah.
Before we announced next generation, we released large dynos because we have been working with the like dynos formation for years back, but then applications start like to require more. Okay, we need more CPU, we need more memory, so we release the XL and XXL dynos to satisfy those needs. And now with Fur, all of those needs are satisfied. And the same has been happening with our database offering. We
Yeah.
keep making sure that our customers have what they need.
Yeah. Let's get into AI.
Let's get into the cool stuff right now, of course.
What are we doing with AI? Like
Okay,
what?
so heroku.com/AI, if you want to see what we announce, we release pretty much one thing was already here, which is PG Vector, a vector database based out of Postgres. Vector databases are like widely used on AI applications, mostly for retrieval augmented generation type of patterns. When you store text information as vectors on a database and you're performing semantic searches to be able to retrieve context to augment the LLM. But last week we released one, it is the Managed Inference and Agents product. Basically, you can provision a LLM model to your application with the same developer experience that Heroku has, with one command or one click. And now you have the model in your app. And it is managed. I mean, it means that it is running on our infrastructure. So there is no risk of your private data going to third-party services. And we support known models like Claude from Anthropic 3.5, 3.7, Cohere for embeddings, and Stable Diffusion for image generation. Those are models that we support, and we are also working to keep updating models and adding more. So that's the part of managed inference. Basically, I can use this service. It uses an API that is based out of the OpenAI compatibility. So you can perform chat completions and use tool calling with local tool execution. The other part is the agents, which is the most interesting. So with the agents part of the service, we have a set of tools that we maintain that can let you access your database on a safe way. So you give permissions to the inference to access your Heroku database, or a way to execute untrusted code, meaning code that has been generated by the model, by the LLM, running on a dyno and generating the output and giving the output back to the inference. And the tools that we support for code execution are right now it's Python, of course, Ruby, Go, and Node.js. So you can ask the LLM to generate Node.js code, and it will create that code, execute it safely on Heroku, return the response back to the inference, and there is many applications that you can do with that. You can also execute commands on a dyno. So this is for running trusted code. So you can have
Okay.
like a script worker or something that is running on your dyno, and you can just use the tool that comes within the agent to run that trusted code. And some other document reading tools. One is HTML to Markdown, the other one is PDF to Markdown. You can pass a document, a URL, and it will give you the contents of that document. So those are tools Heroku maintains that comes within the same agents endpoint. But the other option is, okay, we have this thing which is MCP. Right now, the ecosystem is using MCP to give LLMs the ability to run tools, to execute actions, to get access to external resources. And this MCP became the de facto standard for this type of agentic applications. This is a standard by Anthropic and has been widely used. Recently, OpenAI announced they are adding MCP support to their agents. Google, many other libraries and frameworks to run and create agents have MCP support. And there are like two ways to run MCPs. One is running MCPs locally, which is called the STDIO transport, standard input and output. You are running a program locally and basically communicating with that application with JSON RPC. It is a very simple protocol. And the other one is running on top of HTTP. So the HTTP is a stream HTTP with server-side events or with HTTP stream. And that's a way to access the MCP server remotely.
Yeah. I should point out real quick that those that are catching up on MCP, the idea of MCP, you may have actually already used it, or at least the first time I think a lot of us experience this is in our developer IDEs, when suddenly we had agent mode, and a lot of them they all have different terms,
Mhm.
but we don't really have a standard. But somewhere the word agent is implied or said in there, and the ability for it to not just print what command you should run, but also run the command for you, which means it can see, it can have access to standard and standard out to the shell, and probably there's some pseudo terminal in the background there, but that's all like we just see, oh, the AI can run a command for me now. But what's really happening on the back end is that LLM is accessing tools, and the shell
Yep.
is probably the most universal tool of all, other than HTTP. So it's actually something that we're all inadvertently using. I mean, even if you're using Cloud Desktop or I'm using ChatGPT, the desktop app, and it has access to things on my computer, and this stuff is all happening in the background. Access to file systems, which means it has file system as a tool. Sometimes I think the internet makes it overly complicated and talk about, oh, you can access, your GitHub APIs, and you can access your APIs over your AWS APIs and all these different things. And it's like, well, actually, the simplest example is the one that you're using today.
Yep.
Because we all very quickly, it wasn't that long ago, and some of us are still doing this, that we were all copying and pasting out of a web browser into our editor, and then copy and pasting out of our editor back into the browser. And that was the most painful. I do not miss 2022, 2023 in terms
Yeah.
of the early days of AI. But now that we have this, like you said, this MCP protocol, it's not even really a standard yet, but because it's so brand new, but it is the de facto standard, like you said. And I love that you defined the two different communication methods, because it's subtle, but when you're building these things yourself, you've got to understand those, right?
And I define it because it's very important for the second part also of this release, which is the MCP support on Heroku. Now you can deploy MCPs, like local MCPs with STDIO transport, deploy them to Heroku as you have been deploying all your life with one click or one command, and access those MCPs from the inference service. So the same tool access that we have with the tools we maintain, you can also specify, okay, access this MCP that I already deployed. And we have also the MCP gateway. So you can have all of those MCPs that you have configured for your application, access them through an HTTP endpoint that we are providing. And that endpoint is already with authentication, and it is managing all of those MCPs. So we are adding also that support to pretty much transform that local STDIO MCP into a remote one, which is amazing. And
Yeah.
those are some of the things that I want to show. And speaking of NCPs, one thing that I found super useful recently, I've been relying a lot on AI IDs right now to create my demos. I'm using Cursor recently, but this works with any other IDE that supports MCPs, like Visual Studio Code with GitHub Copilot, or Windsurf, or Zed, or like
Yeah.
Cloud Desktop. All of those supports.
So many things. I mean, even Warp Terminal now has MCP in the beta.
Oh,
So
yes,
like
Ama-
even our terminals will. Yeah.
Amazon Q recently added the MCP support, so you are seeing it in anywhere. So I am not a designer. I don't know anything about like CSS of all of those things, and I recently have been like building more front end applications. And we had like some brand guidelines and instructions on a Figma file online with a lot of different colors, styles, and I don't have time to go and generate the CSS based
Recreate.
out of
Yeah.
that. So I use the Figma MCP, paste the URL, and ask, okay, create the Tailwind CSS theme based off out of this Figma file. And it automatically fetched all the metadata, created the CSS files for me. And I was like, okay, now this is powerful. Now I can do
Yeah.
real things with this, which is amazing.
Yeah. The real things are important.
Yeah, of course. You were speaking something before about agentic DevOps. We also released the Heroku MCP server. So with the Heroku MCP server, you have access to Heroku from an agent. So you can deploy an application, you can scale or downscale an application, get access to logs, provision a database, perform migrations, etc.
Mm.
So now all of
All
those
through an
things
LLM.
can be done also from the LLM, from the
Yeah.
IDE. And why not using the managed inference and agents to create an application that also manages Heroku itself. So it's kind of meta, but
It is,
it
yeah,
is
it is
possible as well.
it's very full circle. I like to use the word meta.
Yeah.
Like it's like, okay, I'm using AI to write an MCP, which is in front of an API that will then be used by my LM while and a lot of us I think are using, because we don't really have a good experience yet. We're all using developer IDEs to have this conversation with an LLM that's really just talking to other APIs on the
Yep.
internet. And I was recently experimenting with Notion, pulling in information from Notion, pulling it in from Google Drive, and then doing some interesting stuff with it, and then writing it back to Notion, and which is just a note-taking app. And I get why everybody's talking about MCP right now, because the idea that the AI can now not just access all of my information everywhere, but also write back and actually make logical sense of something that maybe, or creates something new out of something I already have. That was not something that we envisioned 2 years ago, when we were just chatting with a chatbot, essentially. I felt like, at least for me, it sort of came by surprise when we first started seeing the agent modes and the ideas of these things accessing tooling. It's been a pretty cool thing to be a part of, I think. So if you haven't really dove into what MCP is and tried to get basic, just a bit even just using curl, like just using a basic curl command as a tool for your LLM so that it can run the curl for you, I would say read my newsletter that I just posted last week on MCP, because it's really easy to get started. You can do it in Docker or in any of your developer IDEs, but Docker has a really easy way inside of Docker Desktop to get started playing around with this, because I feel like this is all I'm going to be doing for the rest of the year, honestly. Like just trying to get useful MCP workflows so that we can start talking about, how do we do this in CI? How do we do this for deployments? How do we do this for platform engineering? How do we take advantage of all of this for troubleshooting and recovery of failure? There's just so many scenarios, and so we're not going to be able to cover them all today, but we're going to try.
It's very, very exciting. And this is an invitation for all of you that are now building MCPs. Go deploy those to Heroku. Add the deploy to Heroku button to your MCP so people can easily go click and have the MCP available. That's one thing I did with the open source MCP that I found for Perplexity. I just added the deploy to Heroku button, and it's a breeze to deploy. And we can show that later today in the demos.
All right, let's do it.
Let's do it. So let's start from the beginning. Of course, I'm going to my favorite place in this computer, which is the terminal. And I'm going to start from an application. So I have here an application that I created. It's a very basic Node.js application. I'm a JavaScript developer. I've been doing JavaScript for more than 12 years or so. So this is a very basic JavaScript application that I will deploy to Heroku. So let's create an Heroku application. Heroku create, Heroku Mia app, like manage inference and agents. I'm going to create the application. I have the app, beautiful. And then I'm going to be deploying my app. So this is a Git-based application. So what I'm going to do is the Git push Heroku main. And now my app is going live. So that's the Heroku experience to deploy an application. You need to have your application on Git, run one command, or click on one button, or add it from the dashboard, and then your application is up and running. To enable the model, to provision the model, we are going to also run a command. And you can also do it from the dashboard, and we can show you the dashboard way later. So right now I'm on this Heroku Mia application that I created. Then I will provision a model. So first I'm going to be using the AI plugin that I have already installed, but it's an extension of the Heroku CLI to list the available models that I can provision to my application. So here we can see that we have access to Claude 3.5 and 3.7, the embeddings model from Cohere, and the image generation from Stability, the stable diffusion one. So let's provision the Claude 3.7. So Heroku AI models create, and I give the name of the model that I want to provision. And I'm currently on the context of my application. So it will go ahead and add that add-on to my app. And that's it. Now my application, if you have been using Heroku, you know that all of the configuration variables are stored as environment variables. So if I run Heroku config here, I'm going to see three variables. One is going to be the inference URL, which is going to be the API URL that I'm going to connect. The other one is going to be the model ID, which will represent the Cloud 3.7 Sonnet model that I just provisioned. And the other one is the inference key, which is the API key that I will use to perform my inference calls. And that's how you provision inference to an application.
Yeah. So this has got auth built into it
Yeah.
through the API key. Yeah.
Yeah. One
And-
command, or if you go to dashboard, let's say let's create a new application here. So this is Bret's demo. I'm going to select the CDAR for this, create the application, and now go to resources. And I'm going to search for manage inference and agents and select the model that I want to provision. Sonnet, provision, boom, I have access to it. So now that's how I enable AI into my app.
Right. So it's like you're getting a path with a defined URL. So for those that haven't actually set anything up like this is a very normal workflow where you usually get 2 or 3 environment variables, even if you're running locally. Like I just put out a demo recently of using Docker's model runner. So like running a AI open source model, not Sonnet, but like Llama or DeepSeek or one of the other ones, running them locally. And it's going to be the same OpenAI API standard that we kind of all have settled on. It's going to give you the URL. It's going to give you the name of the model that you need to tell the app. And then for local, you don't really have an API key, but for remote, obviously you need one. So this feels so far like exactly like I would make any other LLM enabled app. Yeah.
Exactly. And if we are going to use it raw, let's go to Postman here. If we are going to be using this like raw with an HTTP request directly to the API, so I'm connected to that base URL, which is usinference.heroku.com, or we also have like an Europe endpoint as well. And the path is going to be the chat completions. So this is the basic inference. And this is following the same OpenAI shape of the body. So I'm specifying the model. In this case, my model is Claude. And then I will send an array of messages, which is going to be the conversation that I'm having in the chat. And here I will alternate between like user and assistant, and I can have like a system prompt depending on how you want to set up this and execute. I'm going to ask a question as an user, what is Heroku? It will perform the call to the inference and it will give me the response. And this is similar shape as the OpenAI API. You can also use, for example, an OpenAI SDK in Python or JavaScript to interact with this endpoint. And here we have. Heroku is a cloud platform. There we have the whole response as it comes in Markdown and all the usage information, the tokens that this operation cost. And one thing about like managed inference is it is a Mether add-on. So it's going to be charged by the token. So the number of tokens that you are using. And that's the very basic of inference right now, which is what you can get pretty much everywhere right now with using an LLM. Since this also supports that OpenAI specification, you can have tool execution from this endpoint, but this tool execution is going to be just functions. So you are providing function with the description of what that function does, let the inference choose the function to run. It will come up with the parameters, and then you locally will need to implement like the function that it will be executed. The cool thing about managed inference is the agents part, which is the agents endpoint. So we have here the agents Heroku endpoint, and we have different tools. So let me go to the documentation page. So I show you the different tools we have. I mentioned that we have the dyno run command. So you can run a command in your dyno. So you specify the function, the tool to run, dyno run command, the application where that command lives, and all of the different parameters for that command. We have Postgres get schema and Postgres run query. So you are giving access to your Postgres database hosted on Heroku, and then it will be able to get the schema, understand the shape of your database before it tries to go and do a query, so it properly generate a real query. Because usually it will try to hallucinate and come up with something that is not necessarily part
Right.
of your database schema, or you will need to give that context in the prompt. So with this tool that get a schema, it is going directly to the source. And run query, similar, go generate the query with the LLM, go run the query and get the results back. My favorites ones are code execution. So I told you before that we have Go, Node, Python, and Ruby so far, support for those natively. But we also release as open source those tools as MCPs. So you can use these externally for your own applications. Or, for example, I'm using this open source MCP code exec Python to have some customization, like install or pre-install some dependencies that I need, have something more customized that the regular tool doesn't have. So it saves me time by doing certain workloads. But these code execution tools support dependency management, so you can specify the type of dependencies that you are going to use for this application. So it's going to perform the installation in Python with pip, Node with npm, etc. And the other tools are like HTML to Markdown and PDF to Markdown, which reads a URL or a PDF file and it gives you the content. So the raw, how can I see this as an HTTP request? Well, go calculate in Python the 14th Fibonacci number. I specified that I will use the code exec Python tool. I will run this. And now this will return the response as a string. And it will go do the inference, execute the code on a dyno, on a one-off dyno on Heroku. So this is not an application that is constantly running. So it's just going to run when this command is executed, then it's going back to sleep. So you are not going to be charged for a long running application, and it finishes. So you see here the messages. First, okay, I will calculate this number. For that, I will use this tool, code exec Python, and this is the code that I will execute. Fantastic. So it generated code, passed the code to the tool, then the tool performed the execution. So this is what the tool returned. The return code was successful. This is the answer. And then the last message is the inference taking that answer and giving you a response, which is what you are going to use at the end. A markdown response, the Fibonacci calculation result, the 14 Fibonacci number is 377. So it's doing that execution. And I can change these from Python to Ruby and calculating Ruby the 14 Fibonacci number. And it will do the same, but now it will generate Ruby code and it's going to execute this Ruby application on the dyno. So here it finished. We see based on the calculation, the response is a little bit different, but the execution we get here, the code exec Ruby. And in the first message, we are going to see the code that it generated, which is this. But of course, we are using just raw HTTP for doing these operations. Sometimes it's hard to see what's going on behind. So I created this demo. This is open source. We can share the URL later. It's on Heroku examples. It's called Mia Inference Chat. This is a React.js application with a Node.js backend that uses Mia. I can select the model that I will execute and select the tool that I will run. And for example, here, let's say print bread in ASCII mode. So it knows that I'm selecting the Node.js tool, that I'm asking for a tool execution, hopefully, and I will see the output in a moment. So let's see if it comes with the proper response. Okay, it say I will create the ASCII version of the name Bret. I see the code execution here. This is the Node.js code that it generated, and it executed the code and gave me the response. So everything is running on the dyno on Heroku. The LLM, the model is doing all that code generation. And now we start like thinking about other use cases. Okay, if I also have access to my database, I have access to this LLM generated code, everything is safe, trusted, is running on the same infrastructure. I'm not leaking any information, but the possibilities are like pretty huge.
Yeah.
And yes, the other models that we support, like the image generation, so generate purple React, why not? And this will use a stable diffusion to generate the image. So you can also have like image generation in your application, or the embedding for retrieval augmented generation applications using the Heroku Postgres. And look at that beautiful image, also created by the model.
I'd take that boat.
Oh, of course, of course, and I love the color, of course.
Oh yeah, that's cool.
So that's the basic of what we are giving, like the managed inference, the tools that we support for agents, and this is the type of applications that you can build. But I have not covered MCP yet. So should we go to MCP demos, or do you have any question?
Yeah, Robot Clock's asking, does Heroku have a means to create mini vector databases like platform, OpenAI, storage, vector stores? I've been using those to create mini MCPs, services for React, Redux, docs, and code samples.
So right now, the support for vector databases that we have is through Postgres. So we support the vector extension. With your Postgres database, you just enable that extension, and that's it. Use it as any data that you're going to store in there. And with Cohere, the model that we host, you can generate those embeddings and store them on the vector database.
Nice.
More things to come. Safe Harbor, I cannot talk about that, but we might have some cool things in our pocket to show recently.
We've got MCP. We understand that like we're giving the LLM access to these tools. And so then it becomes sort of a question of what tools are built in? How can I get my tools on there? Where do I go find tools? And these are all like the kind of questions that I hear. MCP tools are the new hotness. So I feel like we're all going to be walking around with a giant tool bag of like our favorite MCP tools. And for me, it's like lately it's been, how can I use Notion? How can I use all the ones that Docker provides? They have a new toolkit selection, and there's, having access to Chrome, giving it the ability to use Chrome in the background, and all of my internet, anything that I'm storing on the internet, anything in the cloud, I feel like is either Kubernetes. There's already several examples of using MCPs with that. There's everything from Google Drive MCPs to just common Linux utilities having an MCP wrapper around them, so that we can, instead of just having it print a shell command, we can actually have it running the command in the background and understanding the results and interpreting them versus us just seeing raw shell output on our screen. So there's just, I feel like I'm just barely touching the surface with my pinky toe of what's available, but it's still right now, for me learning as like, maybe, I don't know if even this is a pro tip. I have started to have to force myself to use MCP to do things rather than the old way I was used to doing them, like clicking on a website, simply because my brain isn't working this way yet. Like this is actually such a mind shift for us to say, oh, I'm not going to go copy and paste that from that website and then put that over here and then put these things together and analyze it in a spreadsheet. Like it's actually faster for me in some of these use cases to use the LLM with its new MCP tool capability to do all that for me. But I personally have had to force myself to try them and figure out where, maybe using the curl one, for example, maybe asking it to curl a website 100 times and it's actually like running an individual curl command 100 times. Not very efficient. It wasn't in parallel. It was like doing them one at a time in the chat window. And I realized, okay, so that's not a good thing. Like, I have to learn like what things work well right now, what things are maybe not ideal in MCP land. So for those of you out there listening, like it's not like the rest of us have this all figured out and we know all the workflows and you don't. This is still all pretty new stuff that we have to figure out what's useful and what's not. So,
Yeah. And
disclaimer.
also to demystify MCPs, they are like, it's just an application.
Yeah.
You have access to official SDKs. If you go to model contextprotocol.io, there are like many official SDKs that you can use. You can build them in Java, you can build them on .NET, Python, TypeScript, and it's just an application that you build and you run it locally. You can deploy it to a platform like Heroku and adapt like an API or whatever you need for your app. You mentioned like where to find MCPs and things like that. I don't know if there is kind of like a centralized official way. There are many directories that you can find.
Yeah.
The one I use is Cursor directory. There is an MCP category, and here there is a collection of like thousands of MCPs that you can have for your application. We also published our Heroku MCP server here if you wanna use it. And later I'm going to be talking about it. But I want to show the MCP capabilities that a managed inference and agents has. So let's go back to our demos. I have two MCPs deployed. One is the exec Python MCP, which is the open source version that I mentioned that you can deploy to Heroku. It lives on our Heroku repository on GitHub, and you can deploy this by just clicking the deploy to Heroku. And the other one that I deployed here, it's the Brave Search. It's a common MCP that you can find to perform search using Brave. You will need to have like an API key, but I already deployed this. And you can enable or give access to your application to these MCPs. For example, remember that we created this app. We have the Heroku Managed Inference and Agents. I'm going to click on the dashboard. And here we have access to, okay, look, this is the MCP Brave that we have access to. This is how can I integrate these or have access to this MCP through the gateway. So it's giving me an URL with server send event, the token that I will use for authentication, and now I can use this MCP remotely. But I also can use this as part of my agent, as part of my inference. So if I go to Toolkit, I can see all of the methods that are available for me on my application. I can have multiple MCPs attached to my app. And how can I execute that? So the same as another tool, instead of specifying Heroku tool, I'm specifying the name of the tool that I will execute, the name of the tool that is part of the MCP that I just deployed. And here I'm doing a query. What's the most recent Heroku announcement? And this will go and do that search on Brave using that MCP. So the first message is, okay, I'm going to be doing a call using the Brave web search with these parameters. And then this is the result of that tool execution. This is what it returned. And the last one, which is what we are interested in, is the inference process that returned. And now we see that the most recent Heroku announcement, Streamlit, we support like a Streamlit template, and the end of life of Heroku 20 stack, the next generation. So we can see some of the different things that came up with that Brave search. So this is a way to give access to your application to other MCPs by just deploy them to Heroku. How to deploy? This is the Perplexity Ask MCP that I forked. You just need to add one thing to the MCP. So Heroku uses a file called the proc file to define the process that is going to be executed when you deploy the application. By default, we use the web process type to run a long-running application, but we also specified this, and this is new, the MCP process type to specify that this is a MCP. So you can start the name of that process with MCP and then add any other word. This needs to be unique per application because this is used as a namespace. So if you are using multiple MCPs, it is good to have like a unique name here.
Yeah.
And now when I deploy this perplexity ask to Heroku, let's do that. Go and click to deploy. I'm going to be deploying to that theme that we are using. I have a bunch of themes here, but we are using the Mia demos. Let's do perplexity ask MCP. It is available. Fantastic. Now it needs an API key. I'm going to be putting a fake API key right now because I don't have it. So we cannot use this MCP, but we are going to see how to deploy it and how to attach it to the application. And this will perform the regular Heroku process. It will take this application, detects that it is Node.js, install all of the dependencies, and it will keep the application there for us so we can attach it to our app.
Okay, so you're taking MCP, you're adding the proc file to it so that Heroku understands what to do, and then you're creating it like it's a normal Heroku app. I mean, like the
It is a
workflow
normal
seems,
Heroku app.
yeah,
Yep.
but you're saying that because it's MCP, these things are only executed when they're called, right? So it's almost,
Yes.
in this case, they're almost like a lambda or a function as a service, something like that, where they're
Yes.
sitting idle. So if I had 30 MCPs and my app isn't calling them, it's not like I'm being charged for
You are not being
30.
charged for anything.
Yeah,
Exactly.
okay.
Because we charge by the dyno usage. And right now that application is not running on any dyno.
Right.
And when the inference service called this tool, it spins a one-off dyno. So it goes, spins the dyno, execute the application, gets the result, and takes the dyno. So it will only charge for that.
Yeah, like I guess you're caching them so that it'll be faster in calling them and whatnot. So it has to do that initial setup to do. Yeah, because I mean, back in the day when Heroku had free dynos and they would like shut down after a certain number of no
Yep.
requests or whatever, I would always have like personal projects on there that were little tiny apps or whatever, and they would auto spin up and spin down based on HTTP calls. So kind of also like Lambda, but in this case, where these are these are so tiny in some cases, they're just you could almost think of them like as I do a function, is they have like a single use. My curl example or this example of using perplexity to, so I'm assuming in the background, all this MCP is doing is it would call the perplexity API.
Exactly. It's kind
Yeah.
of like a wrapper, but using the MCP specification so the agent knows how to execute this tool. And this is why it
Okay.
is asking me for that API key. If I have access to the perplexity API key, I can just show you how it will perform that query to the perplexity MCP. And then how can I enable that MCP into my application? So I go to my app, go to the manage inference and agents setup page, go to setup, and I attach it as an application. So I will search perplexity, and let's add also that Python one that we have, the MCP Python. So now I attach two MCPs to my app. And if I go to the toolkit, and let me refresh, now I have access to other two tools, the code exec Python, which is exposed by the Python MCP, and the perplexity ask tool, which is exposed by the perplexity MCP. And you can see the namespace. This is pretty much what I defined on the proc file. This start word of the proc file, this is the namespace that I'm using here. And if I go click to this tool, it is giving me, okay, this is the input parameters that this MCP accepts. So the agent knows how to talk to this MCP and what type of parameters it's going to pass. The exec Python receive code, but you can also specify a list of packages. Web search, it uses a query and the number of results that you want to get, etc. But I mentioned, okay, now I can use these within my app, but we also have this MCP toolkit or the MCP gateway where I can expose those tools that I deploy to my app to use them externally. Let's say on Cursor, Cloud Desktop, or any other agentic application that supports MCP. So by using this URL, which is the remote server sent events version for my MCP and my token, I can do something like, here I am in Cursor. I enable the Heroku MCP gateway. So you can see that I'm calling that URL with the authentication token that I specify. And I have access to Brave local search and Brave web search. If I refresh, do I have access to the other ones? Oh, yes. I got access to the other ones that I specify, the exec Python and the perplexity ask. So now I have access to those MCPs that I just deployed to Heroku remotely, and I can use them on Cursor. So it is a way to host MCPs not only for the local inference service for your apps, but also externally through this gateway. So that's another of the powerful things that we have on our AI offering.
While you were showing that off, I was realizing 2 months ago, this was brand new to me. I was drawing out a little diagram. I don't know if you can see my screen, but I was trying to imagine like the flow of like I'm a user in a browser locally. And so you in this case, you have an example web chat app that
Yep.
is just a regular Heroku app. And then that is connected to the MCP tools, and you have a specific tool that knows how to talk to the Perplexity API, but
Yep.
this is all living inside Heroku, right? So
Heroku, exactly.
yeah, so this is kind of like in the safe enclave of Heroku's networking. And then that MCP tool is calling out to a external service. So it's, in this case, it's
Yep.
calling out to Perplexity's API, which is not anything related to Heroku. It's just if someone hasn't heard of Perplexity, it's the AI version of Google search,
Mhm.
and provides interesting results in in an interesting way. And so they have their own API, and you're adding. I think of this as like an API proxy, like these MCP
Yes,
tools.
it could.
Yeah,
Yeah, MCP could be considered sometimes, not always, but sometimes could be like could be like an API wrapper.
yeah, like a wrapper, yeah. And then obviously the Perplexity API returns results to the tool, which returns the results of the app, and then you see them on the screen. So this is all happening with every request that you're sending to the LLM, and it calls out that tool. And
When the inference service decide that it needs to execute that tool, because it depends. Maybe the query that I'm doing, the question that I'm asking doesn't need to run that perplexity tool, so it will not use it. So
yeah,
that's
that's
depending of the prompt. Yeah.
yeah, and like we have multiple MCP tools. So actually, this is incorrect. I would want to do this. I would do this over here. And so if we have multiple tools, the LLM knows based on the human language that we describe these things in. So there is a possibility of overlap if you call two MCP tools. I actually did this just 3 days ago. If you in the MCP definitions, if you're referring to the same tools, two different tools in a similar fashion, it's easy for you to accidentally call one instead of the other. At least currently, that's something I did the other day. So this would be the Brave. Is in this case with your MCP tool for Brave, is it actually running, like, is there like a Brave library? I don't actually know. I only think of Brave as the browser. Is that what we're
Yeah, it is. It is using also the Brave Search API.
yeah.
It
Okay.
is another API.
I didn't know if that was like a service on the internet, like if Brave was providing a search API on the internet, or if this was literally
Yeah,
just
it,
like
it provides a service.
okay,
You can
okay.
create like a Brave account and get API keys. And for free, you can get like a certain amount of queries per month.
Oh, okay, okay.
Brave Search is just doing a search, and Perplexity is doing inference and doing
Yeah,
research and doing thinking. So it's giving you a way different response, just like the list of things that it found on a normal search engine. Perplexity is doing like now thinking and inference on top of those results, and it will give you like a different response.
right. Yeah. And something, because one of the first things I did, I don't know if this is like gonna be the classic tale of people learning MCP. The first thing I did was like I just loaded up a bunch of MCP servers, and like, oh yeah, I want Chrome, I want curl, I want this, I want Google Drive, I want everything I possibly could use, all the tools that I recognize. I just started enabling them all. This is in a similar workflow to we talked about IDEs earlier. That's essentially are the MCP clients. But if I'm running locally, like in a Cursor IDE or something, it's acting as the MCP client. And I made the mistake of enabling too many, and two of them had curl in them. So I was noticing that it was calling the wrong tool because I had two tools that had similar names. And
Mm,
the thing is like we're so used to defining a spec and like calling functions, calling out to a function, and we have a very precise name, and every language has a very precise. You don't make them up. They're like you have to call it that function name when you're asking for that, or you're not going to get that. You're going to get an error. But in LLM land, it's like I'm chatting with a bot. So I have to use words that are going to make it think that it needs to use that. There's no like ID for the tool that I'm aware of that I can tell the LLM, oh yeah, use that tool by ID. It's
Mhm.
not normal to a programmer to talk loosely about, hey, go over to GitHub and pull my PRs for all my repos. Like I'm not
Mhm.
telling it which I have in the background. I have to give it a pat when I configure it, just like you're doing here with your API keys for these APIs. But it's not like when I when I tell the LLM to go do stuff, that I'm telling it which of my tools I want it to do in which order and exactly. I'm just very loosely describing problems to it, and it's figuring out with my human language, my English, how to find which tool it needs to do the job. So this is something that I think all of us will learn as you play around and play with these things, but it's not, I didn't find it intuitively when
Yeah.
I first started using it. At first I was like, okay, but what do I call this tool when I tell LM to do it? Like, what's the name of it? And I just realized, oh, I just need to describe it like a human having a conversation with another human. That's how I call these things. So
And it
anyway.
will depend on the model. Different models do agent planning differently.
Oh, okay.
So there might be like one model that select these tools, and the other model is going to select the other ones depending on their planning
Their mood.
approach.
Yeah,
Yeah.
right, right.
and
Okay.
and last but not least is the Heroku MCP server. So remember I mentioned you can also manage Heroku by using an MCP. And this MCP, we build it pretty much to use it on AI IDEs like Cursor. I have this Heroku MCP here. So let me disable the gateway because you're going to notice something. You were talking about like different tools and stuff. Cursor, for example, has a limit of 40 tools.
Oh,
So
yeah.
if it has more than 40 tools, it starts kind of like, oh, I
Too
don't know
many
what to
tools.
do.
Yeah,
Yeah, Cloud Desktop has support for 100, if I'm not wrong. So it depends also of the tool, the client you are using, how many tools it support.
right.
So let's go with the Heroku one. And we have like different type of tools here for list applications, provision a database, deploy an application, do an inference call, etc. And let's see if this works. So let's go and open a new chat with my cursor, and let's say read the logs of the Mia inference chat app and tell me if it's healthy. So I'm hoping it will now choose the tool, get app logs. Now it's going to Heroku, is getting that information, and it's analyzing. Okay, the logs show that the application is receiving requests, is responding with 200, and it has some Heroku inference logs. It seems the application is normal. Okay. Do I need to scale my app? It will check depending of the logs, if like the metrics that I'm getting in the request response. So now it is doing analyzing the logs. It is checking the instance where it's running, the dyno. And now it is telling me, do you like to proceed with the scaling the application? So it gave me like some recommendations here, but I'm not going to continue. But you get the gist. Now I'm using the MCP and the agent to
Yeah.
perform DevOps for me.
Yeah, and something subtly happened in the background there. Again, for those that are new to MCP, so each MCP server has a list of these tools that it can do, and you're showing those in the middle. Like you actually have you turned off the
Yeah.
gateway, but you're showing the and they have names there, and they don't really mean much to us. We can infer from the way like list add-ons like that I can sort of guess what that means to me. But through my human language that I'm asking the LLM in your chat window, it picked one to use. And that's the moment when you go, okay, yeah, it did choose the correct tool for me this time. Because when you scroll up, people might have missed it if they're not used to this interface. But this MCP client did did tell you this is the one I'm going to choose to get
Yeah.
my answers
And it
essentially.
is asking for permission to
Yeah,
execute this tool. You can do like what people call the YOLO mode, which is execute everything automatically. I don't like that because I don't know what you are going to run. I want to be
right.
sure before
That is
giving you
true.
permission to do it.
I don't YOLO in production, but I definitely like to YOLO. Although they've changed the name now, so it's not as fun anymore. They don't call it YOLO.
Yeah, it is auto execution or something like that. Yeah.
Just call it YOLO. Let's have some fun in our jobs at least.
YOLO was
Yeah,
more risky.
yeah.
So yeah, that's the Heroku MCP server. Do DevOps for you on your agent application. And also, if you are asking, you can also deploy the Heroku MCP server to Heroku, use it within the managed inference and agents. So build an application to manage your own Heroku app. Build an application that manages itself. That would be good.
There is a future scenario, like if I'm not really great at reading tea leaves, but like there is a scenario where there is an AI you got an LLM that's sitting there waiting to be prompted, and we could have a scenario where event alerts, like traditional alerting coming out of Prometheus or whatever our monitoring solution is, it sees alerts and it feeds those alerts to the LLM first, and then that LLM can actually kick off certain tools. Maybe they're in read-only mode for a long time because we want to we're scared of what the LLM might decide. But then the LLM interprets and pulls out some different information and then presents it to the human in more than just, I mean, if you've been doing this long enough, you've designed alert responses, back in the day when I was, first using Datadog 15 years, almost
Mhm.
15 years ago. And for each alert we would set up, I would have to describe the header or the title of that alert, and then you would put in templates into the alert body to show statistics that were coming out of your event, your alert system, coming out of your monitoring system rather.
Yep.
And there is a scenario where those alerts are now being fed to an LLM to begin with, so that the LLM can then decide how severe this is and who to contact. When I'm thinking of
Yep.
PagerDuty, these are all kind of science fiction-y things right now because I think we're all playing around, but no one, I don't know how many people out there are seriously using this stuff day to day, but I just see this as, we haven't really addressed the whole, like, are we replacing ourselves with AI? I just don't see that happening anywhere in the near future. I see this as just augmenting us with more
Augmenting.
data to help us make our own decisions and to do the human aspects of decision making rather than leaving the AI up to make all the decisions. But
For me, it is a tool, and you need to master the tool. This is not my saying. I read this on maybe on X or wherever. But it is not that the AI is going to replace us,
hmm,
but somebody that knows how to use AI might.
yeah,
So
yeah.
we need to be on top of stuff.
Particularly when it comes
And
to MCP. I feel like MCP is the
yeah,
first thing for outside of just writing code in an editor. This is the first thing we've seen that really this agentic idea, but essentially it is the MCP protocol for now. Like that
yeah,
idea is the idea of, oh, no, it can go do stuff now. And that, like, I've been ignoring the race on the foundational models. Like everyone else, we have to kind of read the headlines, but I don't really switch my models every month just because someone that came out with a new Gemini or a new Claude or whatever. But this suddenly made me interested in getting involved with this stuff because this is the moment that felt like this is something I can actually use in my job now. I just have to
yeah.
figure out what I want it to do, and that's the challenge.
A year ago was prompt engineering,
Yeah.
how to talk to the LLM. Right now, the LLM is amazing at creating prompts. So I just like fed what I need to the LLM and I get like the optimized prompt to reuse it again. Last but not least, I want to show you like something more like a real use case, how to use these managed inference and agents into a real application. Well, this is a demo that I built, but this is an application for let's say a solar energy company. I have the dashboard where I can access my solar metrics. And let's say I'm opening that this is the location that I want to check. So here we have two uses. One is the headless use. I just have data. I am performing an API call and I am doing that analysis with an LLM and then getting back the response. And this is what I'm getting here. So it will predict the savings depending of the weather. So now if I go to a different system, the weather is going to be better and it's going to do the prediction and it says it's going to be excellent. And the other one, depending of the weather is not going to be like the weather conditions are not going to be good for my solar system. So now I have that this is not going to be performant. So I'm using a headless agent right now, feeding data and letting the LLM analyze that data for me. And the other one is what we know as the basic usage with an AI, which is the chatbot or the agent. So let me go ahead and open an agent here. And remember that we have these PostgreSQL get schema, run query, code execution. So how can we do that with an application, with my data, and mix everything together? So let's say, okay, what is the average energy consumption in the last 7 days? So I'm asking a question to my agent, and now it's going to start like choosing tools. So it's getting the schema for the database. Before attempting to query the database, it needs to know the shape of the database. When it gets the schema, now it's going to run the query. And depending if it needs to run an application or not, it's going to run the code in Python and then get the response. So we are seeing that it's now querying my database, it's getting all of these metrics, doing some calculations to get the average. And let's see if it needs Python for this one. And when it finishes, I'm going to get the result back on my agent. Okay, it decided to use Python for doing the operation. And it's because I'm in the prompt specifying like also what to use to process the information. So now it's going back to the database. It's going to do a couple of other operations before it gives me the response. But how I'm calling this from my app, if I go to this application that I have here, I have a huge prompt. So this is the prompt for my application. So you are an energy data specialist. This is what you do. This is all the capabilities that you can do. You can generate images. You can calculate data. You have access to different systems through these environment variables. This is how you are going to respond in Markdown with this form. You can access these documents on the internet, etc. And then I am specifying on the HTTP request the tools it can use. You can use PostgreSQL schema on this specific database. You can do run query. You can execute code using an MCP. You can perform HTML or PDF to Markdown operations. And at the end, we can get like a response. Now I have the average. And
Nice.
maybe if I ask create a visualization, it will give me like a matplotlib image here generated with that data from Python. Sometimes I'm getting an issue when it doesn't upload the image to
Oh,
S3, but tries to give me like a route directly in the response, and so I cannot render it. But let's see if it does the proper way to store the image with a pre-signed URL. I specified that in the prompt. LLMs
yeah.
sometimes are kind of stubborn and don't follow instructions pretty well. But yeah, this is using inference, my data, all of those tools to know how like a real agent for a real application. So that's kind of like the power of what you can do with this.
Yeah. That's a pretty cool demo, by the way.
Oh yeah, thank you. In the Salesforce world, we have Agentforce, which is the like kind of like the low code version to create agents with clicks. It's super powerful to work for Salesforce applications. And we can extend Agentforce also by exposing Heroku services or exposing these inference and tools, exposing MCPs. So also Agentforce can access the external world through these tools. So there is a story for like people that just using Heroku for their applications or companies that are using Salesforce and want to extend the agents with more things. See, it tried to do it directly and not giving me the URL, but it generated an image somewhere.
Well, it wouldn't be an LLM demo without us having either a
of,
hallucination, failure of
of
some.
course.
Yeah.
I will leave it in there. Let's see if it works. If not, but that's pretty much what we have. Go again, Heroku.com/AI. Take a look at what we have. We also have our official Heroku official YouTube channel. We have been publishing videos. We have the blog.heroku.com. You can go ahead and take a look at our most recent content. And we are continuously creating content for you all so you get used to all the cool things we have been creating here at Heroku.
Nice. And where can people find you? I'm assuming you're making some stuff or talking about stuff somewhere online.
Of course, of course. So you can find me on X with Julián_Duque. And you can find me on bluesky.co. Julian, like my name, or Julian. I don't use that, my Starbucks name. I'm from Colombia, so I will use my Spanish name better. And I write content for the Heroku YouTube channel, the Heroku blog, and we are also going to relaunch the Heroku podcast. So you're going to be hearing my voice pretty soon. So stay tuned. We have a lot of things in our kitchen getting prepared right now for you all.
You heard it here first. Breaking news.
Yeah, breaking news.
Podcast is back, baby.
Oh, yeah.
Okay, I was going to throw back to my diagram real quick. So I'm realizing I've actually got something I'm leaving out a little bit because this is a little too simplified. Over here we have Claude somewhere, actually.
Oh yeah, that's the inference model that we are using.
Yeah. And so I'm not sure if you described it, but in this case, you have a web app that is essentially a chat interface. We're going to call that the Heroku app. Is it passing everything to Sonnet on the back end? Like, is Sonnet living inside Heroku? Like, you all are provisioning those, right?
And that's where the managed inference word comes from. It is running on our infrastructure. So we are managing those models. When you are doing the inference or the LLM call, you are going to the Heroku backend.
Right. And so the Heroku backend of Claude is actually, isn't it what's calling the tools, not your web app directly? Is this a better?
Exactly. It is the inference, service is the one that makes the decision of what to call, get the result from the tool, and now give you the response back.
Yeah. So in your case, your front end web interface demo is actually simplified by the fact that it's passing this stuff back to the LLM. The LLM's doing all the work, passing information back, and then it's just doing pretty printing, figuring out how to display Markdown in HTML, how to have that React native experience kind of thing. Yeah. Okay.
That's pretty much it. You saw on the Postman example, it gives you like a streaming response, like OpenAI-like kind of response, and then you process that and show that information in your app as a chat or as a headless agent, or depending who you want to interact with it.
Okay.
All this code is available. Go to github.com/Heroku-examples. We have many demos and things that you can see. The chat that I show you initially, the chat application, it's called the Mia Inference Chat. That's open source. You can go ahead, clone it, see how I build that thing, run it yourself, modify it to suit your needs. And the Luminar Solar application, we are finishing some things. It is already open source, but we are continuously adding more features. It will have like a dual agent support, one using the Salesforce Agentforce service and the other one using managed inference for custom agents. So that's also something that you can see how we build that. It's available on the Heroku examples org and GitHub.
Well, this has been awesome. I'm excited to play with it. Now I just need to get someone to buy me some credits.
Yes,
this is some fun stuff. This happened to me recently with Docker and their idea of how to give you local MCPs on your local system through containers. And this feels like the internet equivalent of that. Just an easy button for, I don't have to be a machine learning expert. I don't have to know how to run GPUs. I get to take advantage of the foundational models you provide. And then I can go find MCP tools that I want to use, but then I don't have to actually run them myself and figure out how to dynamically load them and then dynamically shut them down so that I'm not constantly running a bunch of pods everywhere. It does feel very Heroku-like, I have to admit. It is an easy
That's
button.
The Heroku for AI built by Heroku.
All right. Well, you heard it here first, people. It launched this week. We had him on the show. Perfect. Thank you so much, Julián, for being here.
Thank you for having me.